Welcome to the 13th episode of Byte-Sized JavaScript. Here's how our code was looking like when we left off. As a quick wrap-up, we had a bin/fetch script whose sole responsibility was to fetch information about the channel's YouTube videos and cache the data locally for later retrieval. Last time we were fetching the data, but we were not saving it anywhere, so now we'll create a data folder to save our API responses to the file system so that we can reuse it later. And inside the data folder, I'll create two files. One of the files will be named videos.json and the other will be tags.json. And videos.json will store meta information about all the videos that the channel has basically. And tags.json will be kind of a reverse lookup table. I mean, it will help us find which videos are related to a given tag. So if I give a tag name, it will go and find all the videos that have that tag basically. I'll also move the timestamp file into this data folder because it makes more sense there, and it will also help me clean up some of these npm scripts basically. I will also add a watcher task so that I don't have to transpile my files over and over again when I make a change. And as a preventative action, I'll back up my cache file before doing any operation on it, just in case, I'll also export and use the YouTube API credentials as environment variables inside this file. And you should be extra careful not to put this file into source control because it contains authentication information that should not be shared with anyone else. And in a production-like setup, this environment information is generally provided by a infrastructure automation system like Chef or Puppet or Ansible or SaltStack maybe. And that's all we have to do for the npm scripting part for now, at least I think. And for the API key part, it should look something like this, where you inject your own YouTube API key instead of this text. Now let's go to bin/fetch.js, and since we are writing to the file system, we'll need the write_file method of the fs module as well. And for dealing with timestamps, I'll be using this moment library. So let's install it by doing a npm install moment --save. And I'll also create a bunch of path variables. First of all, the timestamp file has moved into a different location, so let's fix it first. And we'll also add paths to the video.json and tags.json. And I'll provide a filter of which fields I want out of that API, which will be really useful because the footprint of the JSON that I get will be small. It will be faster to parse, faster to execute, faster to iterate through. And I won't be wasting the precious CPU cycles of my server eventually. So when the response comes, I'll parse it and get a list of videos out of it. And I'll filter the response and I'll only take the items that are YouTube videos. And let's also add this guard clause so that for any reason, if I'm unable to find anything, I return an empty collection. And the data that comes from the YouTube API doesn't come all at once, it comes in a page-by-page basis. And I want to fetch all those pages and aggregate and merge all the information that they contain in a single collection. And to achieve this, I'll start by adding two parameters to this function. One of them will be token, which is the next page token, and the other will be an accumulator, which we will be populating along the way in a recursive fashion, so to speak. And if we do have a token, I'll pass that token to the URL as well. So let's push the items that we have filtered out of the accumulator first, and then resolve our promise with the accumulator. However, if we have more items, that is to say if there is a next page token, we don't want to resolve our promise immediately, and instead we want to resolve with the resolution value of a follow-up promise or a follow-up fetch operation basically, which we will obtain by calling the same function with an updated token while we'll be passing down the items that we have already accumulated. And we'll recursively chain this promise until we have no more pages left. And let's move things around a bit. I will move this entire file into lib/fetch.js, and in bin/fetch.js, I'll require the transpiled version of it, which will be in releases folder. And I'll also update the package.json to transpile everything under the lib into the release folder. And I'll have to adjust some of the paths that we have in the source code to adhere to this new file structure. And while we are into isolating things, I also want to isolate the file input-output operations. So I'll start with creating a read file and write file methods that will have promise interfaces and that will read and write to files, and it will be as simple as that. And there are promisification libraries out there. Bluebird is one of them, for instance. However, I just wanted to show you that that kind of a thing can be done with a couple of lines of code so that you don't have to use a full-blown library just to promissify a bunch of methods. And while we are modularizing things, I also want to isolate our logging module so that we can use it like a facade. And the reasoning behind this approach is if we want to change our logging mechanism, or if we want to use a different logging module like Banyan or Winston or something else, we'll only have to modify this part of the source code and we won't have to touch the rest of the code base. And creating an adapter or a facade this way is the initial step towards following the open-close principle of software architecture design. Now let's go back to our IO.js. If there is an error, we'll be rejecting the promise, and if there is no data, we will resolve with an initial seed value that we pass to this function, and if there is some data that we get out of that file operation, we'll be resolving with the data. And write file method will be similar. We'll be persisting the data into the file system and we'll be resolving with the data that we have persisted. So in fetch.js, we'll use this new read file and write file methods. We'll be reading the timestamp file as a string, and if the value is empty, we'll use the current timestamp of the current date as a default value, and then we'll do stuff with that timestamp basically. I'll also comment this part out since we'll be rewriting most of it as well. And since the general theme of this episode has been isolation so far, I also want to isolate this time-related operations into lib/time.js. So I'll move the moment.js import here, and I'll also abstract a now function out of it, so that if we decide to use another timing library or if we want to add our own timing functions, time.js will be a nice place to bundle them all. And also this getVideoSince method, I don't know you, but it's totally related to YouTube API. So I feel like we need to move it to an API object of its own. So I'll create a lib/API/YouTube folder, and then I'll create an index file inside that folder, and I'll move this entire logic into that file. This way I can further abstract the business logic by creating a getter function that just takes a timestamp and resolves with a list of videos since given that timestamp by reusing this relatively complicated logic by abstracting it away. And while we are refactoring things, I also want to move all these constants into a configuration module. So I'll move them into lib/config.js. And we'll modify our source code to import those constants and use them from that file. I also want to move this lower level IO functionality to lib/io/core.js and then create an index.js inside this IO folder that uses that core functionality. And we'll initially create two methods in that index.js. One of them will fetch videos from the cache and resolve with a JSON representation of the fetched data, and the other is the one that fetches the last updated timestamp, which leaves our lib/fetch.js entirely empty, so we'll kind of rewrite some of the code that we commented out. So first, let's import the fetch videos and fetch timestamp functions that we have just created from the IO module. So we'll be fetching videos from our cache and we'll fetch the last updated timestamp. So this code is good enough to get our existing videos from the cache, and then we'll fetch new videos from the YouTube API and merge them. And we need to fix a few minor things. One of them is obviously default exports don't work this way, so we need to tweak it a little. So let's also update this timestamp so that we can actually get some videos from the YouTube API. And when we do an npm run fetch, we get an empty list of existing videos because our cache file was blank initially, and we get a set of new videos, which means our fetcher is working accordingly. And that's a great point to stop. You might feel like we haven't done a lot, but in this episode we have refactored our YouTube API fetcher code to make it more modular, more robust, and more reusable. And those are really important things. And in the next episode, we'll continue from where we left off. First, we'll enrich our data by calling additional YouTube API endpoints to get more information about our videos. And we'll be actually persisting those data into our cache files, which are videos.json and tags.json, so that we can reuse them later. So until then, may the source be with you.